Hello, Narnach here. Welcome back to TIS-100. And this episode we'll be looking at the histogram viewer, which is yet another one in the series of image-related puzzles. So let's dive in. What's a histogram viewer? Well, we have to output an image like this, and that is all based on a series of numbers that we receive in the input. And each number corresponds with the height of a line. So this is a histogram that's basically it's a chart of columns, or histogram. It usually counts frequencies and things like that. And we get the length of how many items there are. We have to just plot them. So there's a number of aspects to this. First of all, x0 is all the way on the left side and it increments to the right. Y0 is at the top and it increments downwards. So the fact that we have to draw the image from the bottom up means we have to reverse the values. And after a little bit of experimentation, I discovered that the height of the image is 18 pixels tall, or 18 blocks, or however you call it. And it starts at 0, so the highest possible value is 17. That's basically our 0 is 17, and from there we count down for every point that we need to plot. So we have to keep track of a number of things. So there's actually quite a bit of work involved in drawing a picture like this. Because basically the way we approach it is we take a number. So the first number we start all the way on the left side here on x is 0, and then we just put a block down, and we do that 8 times, and each time we move our cursor up until we have plotted 8 blocks. Then we reset it all the way down, advance 1 to the right, and we check the next number and we plot that one, and we keep going on that way. So we have to keep track of where our x-coordinate is, because each number we have processed, we need to move it 1 to the side. So that we have to store it somewhere. And in this solution, I've chosen to store it in this node. On the other hand, for each of the values that we receive, we have to keep track of the current y value and where we have to go. So that's also a relevant option. So in this case, we track the y value over here. So let's just walk through the solution. I mean, this is a bit of an overview. Let's walk through the solution and see how we do it. So numbers come in here. We plot the image over there. So we connect it, and in this case, I'm using 5 nodes. X logic is here, Y logic is here, and there's a little bit of control logic over here. And in the scores, you can see I have done 2 attempts so far. And basically the difference between the two is that I've inlined the main loop. The main loop that I've got over here, I've inlined it over there to make the code slightly more efficient. It takes 30 cycles less. So basically optimizing this really doesn't matter all that much. So what do we do here? So first step is we take the number and we store it in the accumulator. Then we send the value 1, we send it down. We send the value of 1 to the right. And then we subtract 1 from our stored value. And after that, we, as long as the number is greater than 0 still, we loop. So we send 1 down, we send 1 to the right, and we go back until the value is no longer greater than 0. Basically, when it is 0, because numbers are always positive. After which we reset things by taking the new number, putting it in the accumulator, and sending 0 down and to the right. After which we go back to the loop, which is an inline version of the loop. So why are we sending zeros and ones? That's based on the protocol I've set up here to make things work. So, because there's a number of fixed assumptions we know about. We always know we start on Y17. So that's 18 pixels down, that's Y17. We always start there. We also start on x equals 0. So That's if we look at the y value, we have a setup step where we set, okay, our accumulator is 17. That comes across with the y coordinate. Now we swap it, so we store it in a buck. And then we wait for a value from the left side. So the 1 and the 0 are control coordinates. If we receive a 1, we need to output the number and basically continue. So in the case of the y, whenever we receive a 1, we reduce the number by 1. So we will, the next time we receive it, we will be ready for the next pixel, and next pixel, and next pixel, and next pixel, until we receive a 0, which happens when we are done, and then we reset here. So let's see. Basically, we reset by jumping back to the loop. So the loop is very tight in this case. We just get a number from the left. If it's equal to 0, we jump back to the setup, and the setup equals the reset. It's very simple that way. Otherwise, we output by taking the stored number back, putting it in the accumulator, sending it down, subtracting 1, and putting it back. And that just repeats. And for the x-coordinate, it's even simpler. And there, the modifying of the stored value happens in reverse. So during the loop, we take a number from up, we put it in the accumulator, then we check it. If it's equal to 0, then we increment the value. Basically, that means we reset. Otherwise, we just retrieve the stored value and we send it to the right, after which we just swap it back and we wait for further input. And the increment, we swap out the original value, we add 1 and we swap it back. It's really, really dirty because because while we are processing a number, we need to work with y. When we're done, we need to move to the next line and reset. And the image renderer, all it does is take the x-coordinate from the left, it takes the y-coordinate from the top, it sends color code 3, which equals white next up, and after that it sends -1 to indicate it's done. Okay, since the image renderer format, it draws lines, and lines are always length 1 in this case, because we draw single dots. And if we draw this, then you can see exactly how it works. And we can advance this, and it works for all kinds of random inputs. So here we use 5 nodes and just over 2,500 instructions. And as far as the high scores are concerned, the efficiency here is pretty good. This is top tier. Node count and instruction count are not. So that's why, contrary to my usual solutions, I didn't have to optimize much further for cycles. I actually had to optimize for reducing the node count to 4 and reducing my instruction count. And eventually I managed to succeed in that. So I want to highlight this as well. So in this case we are using 4 nodes. And we have 2 transportation nodes that just pass numbers down. Then we have 1 node here that stores x and has a number in the accumulator, so that's basically the countdown. And in the right side we do the plotting and we do our y processing. And that way we use the ACK and the BAK in both of the nodes to the fullest extent to cram all the logic in here. This is actually a pretty good way to reduce the instruction count as well. Excuse me. So what happens here, we take actually just run it first. And you notice it's slightly less efficient, quote unquote slightly. It's almost double the number of cycles, but it is more efficient. So only 4 nodes. And there is a solution that has less instructions. Should be able to do it in 22, maybe even 21. But so far haven't managed to do that yet. So Yeah, this is good enough as a first solution. So let's dive in to see what happens. Because before we had a control node here that handled all the logic for counting down. And we had a full node dedicated to X, and the same, we had a full node dedicated to Y, and we had a node dedicated to rendering. And now it's all been inline. So was anything lost, or did things just get more efficient? And the thing here is actually that it got more efficient. We only need to do two things. In this case, we store the X value, which whenever we are done rendering a bar, we need to increment it by 1, and otherwise we just pass it through as it is. So there's really nothing fancy going on there. And while we are in a bar, we need to keep track of how far we still have to count down. Because remember, we have to keep track of the Y coordinate that we are rendering and the target separately. So that's why we do it like this. So we take a number from up, we store it. That's going to be just the number that we have to render. Then we swap, so we take out the X coordinate, which we then send straight to the right side. And then the left side, then this node will pass it down. After which we will swap the X coordinate back, and then we take our number. We subtract 1. And then as long as it's greater than 0, we loop back. So that's basically all we do to keep track. We start with the number, we send something to the right, we subtract, and once we hit 0, we are done with that. In which case we pass -1 to the right side, so we know -1 to be a special value. After which we swap and add 1 to X, and we swap it back. So there's not a lot of exciting things going on except for this -1. So why do we do that? Well, the thing is, on here we need to know if the value we get, if it's the relevant value. Basically we get an X coordinate, which can be anything. It starts at 0. So 0 can't be magical, and after that it's going to be positive integers just incrementing 1, 2, 3, 4, 5, etc. So -1 has to be a special value to make a distinction that it's not an actual value. And this way I can get away with only sending one number. The alternative would be to send two numbers, like a 0 to indicate, hey, the next number that's you're gonna receive is an actual coordinate, or a 1, which indicates that it's, that we're done. But in this case, because I can use -1 as a special value, I don't have to send two values, I only have to send 1, and then the way the logic actually fits in a single node. So what we do here is, once again, we set the accumulator to 17 to indicate that we are rendering all the way at the bottom for the Y coordinate. And then the first thing we have to do is process the X value, which we get from the left, which can either be an X value or it can be -1. So we actually need to store it. So that's why we swap out the Y value. We put the value we get from the left in the accumulator. And if it's less than 0, so that means if it's -1, we are done. We jump back to the setup. Otherwise, we send the value we got straight down. So then it's going to be an X coordinate. So after that, we fall through. We swap back to the Y value that we just stored previously. So we take that back. And then we send that down as well. So at this point, we have sent the X and the Y value. So then we subtract 1 from Y to move the Y coordinate up for the next pixel. And after that, we send the color code 3 to indicate it is white, and -1 to close it down, because once again we're just rendering pixels. And after that we jump back to X, because we skip the setup, because the setup is only meant for when we receive a -1 as an X coordinate. And this will get us the result we need, as I already showed before. It's less fast, but it uses less instructions, and usually that is an unfortunate trade-off that you make. If you want things to be fast, you use more node and more instructions. If you want things to be compact, the price you pay usually tends to be that it's slower or less efficient. So, well, that's actually all I had to say about the histogram viewer. It's as far as I can tell, it's the last one of the basic image puzzles. So the next 4 are going to be more complicated than this. So I'm looking forward to see what happens there. But that's going to be for a future episode. So as always, if you have any comments or ideas or suggestions or better solutions, please do leave a comment. I appreciate reading them, and other people probably will as well. And that's also, if you have figured out a better way to do this, check the comments first. Maybe someone has already solved it and left a comment as well. And with that, don't forget to hit the like button and the subscribe button if you haven't done so already. And then I'll see you again in the next episode. Bye bye.